what did you remember from last time? What did we achieve?
We went over like some complex numbers, everything like that. We talked about the equation.
Okay. So complex number was second part, and what was the first part?
What are like hypothesis, like of the angle of the wave is the action accumulated by the electron?
Yeah. So something about action of an electron and phase. So what's the relation between action and phase?
They're the same.
Huh?
They're the same. They about
With,
the action.
with precision up to a factor. Like 2 equals 5 with precision up to a factor of 5 over 2. So what's the factor connecting phase with action?
The planning.
Yes. So the action has dimension of what?
Joule seconds.
Yeah, energy times time. Some people may go away from joules to some other units. But energy times time and phase angle doesn't have dimension. So we need just this joules times time factor to convert from one to another. Why in the world we need this part? Why do we need this action and phase? So with our hand wavy discussions, right now everything is not very solid, but through the discussions we are building concrete foundation for more rigorous theory, and we need some ideas that will help us to perceive the equation, that help us to understand what stability of molecules and reactions and characterization towards physical chemistry. So by some reason we started to learn theoretical physics instead of physical chemistry and going through action and with action principle. How does it help us? Even if you can convert action into phase, why do we need phase? What was our motivation? Or from your point of view, what was the motivation of this strange man in front of us? What was our departing point? Where did we start to think?
We can use it to like define a new wave like motion and like the physics at quantum level.
Yes, very good. I cannot say it better. So we know the idea that no one was objecting the idea that some wave motion occurs in atoms. The electrons, at least in oversimplified Bohr's model, perform some wave motion, form standing waves with discrete integer number of lobes and nodes. And if there is a wavy motion, it is controlled by the argument of whatever trigonometric function, harmonic function, exponential function, which just linear increase of phase in the argument corresponds to the wavy motion of this function where this phase is inserted as argument. So it can just linearly grow with time or do something more complicated. So we have feeling that there will be some sort of wavy motion, and typically to mathematically describe wavy motion, we need an argument of a wave, mathematical argument, not argument. The angle is an argument of any oscillating function, and it was our big discovery, big philosophical advance that we agreed to advance that you were not objecting, that one can compute action, convert it into phase, and plug this phase as an argument of some oscillatory function. Phase argument. And from one meeting before, no one yet caught me lying, but we all caught me saying something irrelevant to physical chemistry. The wave equation that we derived on our meeting number 2 is irrelevant to electrons, but we need a replacement of a wave equation, and you can. So we need a replacement of a wave equation which will be applicable to electron. And we want to do it, well, we can declare it right now, was many of you know Schrödinger equation, right? But if you do not go through fundamentals, then it will be just boring symbols on the board. But the equations are not precious thing themselves. This is good enough.
Okay.
They just reflect some ideas. And what we will be doing through the course is convert ideas into equations and equations into ideas. Hopefully making some relevance to molecules, chemistry, and physical chemistry and characterization. So what is our goal? Okay, guess what is my goal? In frames of the course. So let me repeat the same introductory material and then bring you to the right conclusion, or to what I think the right conclusion. So we agree that there is some wavy motion of electrons. We agree that it would be nice to have a wave. We already have a wave equation for other nature of waves. And we have some background ideas about electrons. What do we need?
Trying to find a wave equation for electrons.
Yes, we need a wave equation for electrons. It is our goal for today and Friday, for 2 meetings. If we would meet for longer than 15 minutes, we probably could squeeze, but I do not trust. Let's do slowly but surely. So wave equations for electrons. So we will come to it as result of our discussion and analysis. And it will be something that we will use through the rest of the course with much better confidence and understanding of the background. What is the main achievement of classical mechanics and Newtonian equations philosophically for the human society? Not for designing a little more devices, but in overall understanding of the picture of the world. So let me bring it up, and this idea is really exciting. It was affecting a lot of thinking, not only in science, but in much broader range. So in Newton equation of motion for any system, you do set equation which is same all the time, just different degrees of freedom, and you set initial conditions, like position and momentum of whatever. Like a table, or a car, or a human that was thrown off from the tower. Well, I should select something more humane. And then, if you take these two inputs, initial conditions and equation, you can solve and predict the future. Like, I predict that it will fall. Maybe it's again not a smart idea to drop equipment, but so thanks to Newton, or he was enjoying apples falling to his head or something. That's what it is. But it means that the world is deterministic. So if you know the past, you can predict the future. If you have enough skilled mathematicians, or if you have powerful enough computers. So for any system, we just set up positions and velocities, learn, solve equations of motion, and we predict what will be the future. which means you can control everything, or you can know everything in the future. This is a very, when you think about it, you feel yourself powerful. It would be really great to predict the future of electrons. But we know that Newton equation of motion will not help. So one of our goals, why do we, on more fundamental level, it's not the equation that we need. We need a power to predict the future of electron. If you can determine its past, we want to know how it will evolve in time. But the complication is that it is not a point or system of points. It is like infinite number of degrees of freedom. It's some wavy nature. So we need to predict future of a wave with understanding that our wave is an electron. Any objections or questions? Does it seem like reasonable thing to analyze? Okay, well, I do not see super enthusiasm, but until no one is falling asleep, which is a good sign. So we went through the review of what you were doing last time. So we went through action as an argument of wave motion, and we briefly set up mathematical background to deal with complex numbers, because they will pop up. Good. So finally, what is oscillating? What is the wave in Bohr model? What is the nature of this wave? How to interpret it? Do not tell that no one took modern physics or didn't heard about wave function. So, any ideas?
It's related to the probability of finding the electron.
Yes. So it is a wave of probability, or more, more specifically, it is amplitude of probability. So the thing that is oscillating in the atom is a wave which will give probability to find electron if you take it absolute value squared. So the thing that we are working with, the wave, we will make it depending on the position and time. And if we take complex conjugate multiplied by itself at the same time, this can be interpreted in two ways. Either as a probability that in the interval from x to x plus delta x at time t we will find an electron, or density, how many electrons we will find at this point of time and space. 95%, maybe 99% of scientists support the idea of probability, but at the time of developing quantum theory, there were debates, and still some people want to believe that it is density rather than probability. But for us, it doesn't matter, just two possible interpretations. Math and equation do not depend on how we interpret the results. So if you have the function, which can be negative, then we square it, which makes it always positive, and then we tell that it is probability as function of x and time. So at this point, there is a highest probability to find an electron, or if there are many electrons, or electron can be split on percentage, like 30% of electron can be found in this spot. So the nature of this electron that it is, you already taught me about duality, right? So you cannot tell that electron is located at a specific position. It is so vivid, it doesn't want to stay still, it moves in wavy form, and there is a probability finding here and there. So it is distributed object. And if we know the wave function, we know where this distributed object has higher or lower probability to be. So we know this distribution of distributed object. Okay? Probability. So we cannot do everything at once. We need to divide and conquer. And let's divide two parts in an analogy to classical mechanics and Newton. So there are two parts, equation and initial condition. So suppose that a good colleague gave us an initial condition, or it is so evident that we know it. We know the distribution of electron at initial moment of time. But we want to be so powerful and predict the future, to know what will happen to this wave function upon a time. Will it move somewhere? Or it stays there, the same place, or will perform something strange. So we need to find a connection between past and future in a sense of predicting electron. Also, there is an in the concept of divide and conquer, we cannot immediately jump into metal-organic framework molecules or some complicated chemistry. We even it will be too hard to start even from hydrogen atom. So at the beginning of the course, we will think about very simplified models where electron moves only along one direction instead of many. And later on, we will use another toy model, a hypothetical universe that has empty, has nothing except one electron moving in it. Well, it's a little boring, but without these models, we will not get to sufficient level of skills to analyze true systems. So at the end of previous meeting, we agree that if you do know the action for a given trajectory, we can divide by Planck constant, and the wave function will somehow depend on this construction, right? We are going to use this fact for predicting future, and we will try to go from the past to the future in the same concept of divide and conquer. We will split the timeline onto small intervals and see what happened on each small interval. And through this discussion and arguments, finally, by the middle end of Friday meeting, we will come to wave equation for electrons. So suppose we know the past and we set up a goal to know the future. So we want to establish connection between wave function in the past and wave function in the future. So we need to find what will be in this line. How do we go? So hypothesis one, that wave electron, as it moves, accumulates phase. And accumulation of phase changes the wave function. Why don't we put this exponential in front of wave function, telling that if you go forward a little bit in the future, it makes nothing but changes its phase. So multiplies it by complex number, by exponential is imaginary of some phase. So we propagate in time, and wave function just changes its phase, oscillates. There is one non-logical cheesy place that being debated, and later on, after well, about half of a course, we can return to it again. But there is a return from Lagrangian that forms the action back to the Hamiltonian, and there are arguments to do it. I will skip it, otherwise we will die of technical details. So the action on the small interval that determines as phase is as our starting point of classical mechanics should be value of Lagrangian times length of time interval, but with some additional logic, we can, for infinite with small time steps, we can go into value of energy for a system at a given time times length of this time interval. So if we accept this idea, this concept, we will be able to propagate, to change wave function a little bit forward in time to see what will happen in the near future. So it is a factor that is being multiplied to wave function each time we make a step forward in time. So we find the value of energy multiplied by length, use it as an divide by Planck constant, and use it as an argument to exponential. And the idea is stemming from classical mechanics, from action, at least action principle. So if we repeat it again and again, then these steps of phase accumulation add together, and the thing that connects past and the future, that allows past to evolve in future, is referred to as evolution operator, and we often use the letter U for it. So move forward in time. Objections? Questions? Counter arguments? No. Okay. No, it's two pieces slide. Let me probably write, and then we'll go to the summary. So if we split our timeline from the past to the future as a set of small time intervals, delta t1, delta t2, and then delta t n. Then at each time step we will have the evolution operator of delta t1, delta t2, many other evolution operators u of delta t m, and they will act subsequently on the wave function at t equals 0. As a result, this set of evolution operators can be considered as a sequence of small events of evolution. So if we do have initial wave function and the evolution that has been performed during the very first short time interval, then it will generate us infinitesimal, very near future prediction. So it will be psi at time 1, right? Then we apply the next evolution operator to it, delta t2. And then this will generate wave function at t2. And then if we repeat this sequence of evolution operators, we will arrive from the past to the future. So each little time we accumulate, electron accumulates a little bit more phase, wave function experiences a little bit more oscillation. Okay, same thing. So we go from past to the future. We start from initial wave function and we do infinitesimal time step forward. That gives us near future. Then we apply next small evolution operator and we go to the next step in the future. And if we propagate it through sequence of these steps, we will arrive to whatever we have at the end. So we go from the past to the future through the sequence of this evolution operators, through the phase accumulation process. How do you multiply exponentials?
Add the exponents.
Yes. So why don't we do the same for this evolution? So right now we have product of small evolution events, but we can set it up as a single exponential where powers of all these minimalistic exponentials will be added together, okay, based on the property of exponential. So it will be E, and then h1 delta t1 plus h2 delta t2, so forth, hn delta tn minus I h bar, right? And then if we know how the Hamiltonian depends on time, we can formulate it as integral from initial time to final time. And tell that this is our evolution operator. Getting together and having evolution operator. So please tell me your concerns about this idea, or if there are no concerns, means you're happy with it. how can we summarize what we achieved by now? Although I do not observe much of enthusiasm, but it is a really important achievement. Again, this method is not very practical, but in fact, we do not have equation. We do not have differential equation to solve and generate electronic waves. But we have an alternative way to predict future, to generate the waves based from the initial condition. And in addition to solving differential equations, there is this way based on evolution operator that can predict and model any realistic system and give the right answer. It's just not very comfortable for solving. So Richard Feynman got Nobel Prize for developing this alternative approach to quantum theory instead of Schrödinger equation. But we will go to more classical in second or next. Okay, we have 30 minutes. So right now we have an idea how to predict future of wave function with this evolution operator. Are we happy or not quite? No, we are probably not happy because it looks odd and it doesn't look like anything we did before. So it may be philosophically okay, but practically it is very uncomfortable from our, even if all of us do experiments in wet chemistry lab, but from what we know about science and theoretical science, this is very strange. Typically, we have equations that we need to solve. Here, it is multiplying something. It's odd way to predict future, and even if one goes along this way, it will be too much of writing. It's not most efficient way. But this is a bridge to the equation that you, to the Schrödinger equation that you may have heard of, to the equation that will generate waves for electrons. So if we run out of time, I will continue after the break on Friday, but I will start now. So the goal is to obtain differential equation that generates waves. The supply, intellectual supply that we depart from, is this way of predicting future with evolution operator. How do we get to equation? We will do a little numerical experiment. Mathematical experiment. So we will explore how will this procedure for predicting future respond to derivative in time. We have wave function. We know that wave function is a product of evolution operator and wave function at initial time, right? It is what we were talking before. Now, how do you take derivatives of products?
Or wait, yeah.
So we can be confused with names, but tell me an algorithm. If I have product of two functions, and I want to take derivative of them.
It's like f h prime plus f prime h.
Mm-hmm. Everyone agrees, right? So let's f h prime plus f prime h for f h brackets prime, right? Let's apply it to to this situation with wave functions. So psi prime will be u prime times psi 0 plus u times psi 0 prime. Right? I still need to learn your names, so can you introduce yourself?
Yeah, Austin.
Austin, okay. I promise by the end of the course I will know everyone. But it will take a long time. But if the initial condition is provided to us by someone else, we cannot change it. It is a slice in a given time. It means that time derivative, which is symbolized by a prime symbol, of the initial condition will be what? Guess equals what?
0.
Yes. So because it is time independent initial condition, so we drop this term. Now we need to take time derivative of the evolution operator. T exponential means exponential sum of something. H bar integral of Hamiltonian dt. So the integral of the Hamiltonian of energy operator is needed only in case the energy operator changes in time. But in many practical situations, the Hamiltonian is time independent. Then it will be just dt e times over h bar h times t minus t initial. How do we take derivatives of exponentials? What is e to the power x prime?
E to the power of x times the derivative of x.
If x is a function, yes. And if it is e to the power t, no traps.
Just E to the T.
Same. Like e to the power t prime equals to the e to the power t. So everyone loves exponential, and it is plugged into this course so intense because it is very well treated by any calculus operations. So the derivative of exponential is exponential, integral of exponential is exponential, product of two exponential is exponential. So it's very hard to get away from exponential if you start from it. So, and it is mathematically much simpler than any other function. So what should I write here? We will get the same e to the power minus I h bar h times t times t0, and as a price for taking derivative, we have this factor popping up in front of the result. So by taking derivative of the evolution operator, we get minus I over h bar Hamiltonian times the evolution operator itself. So derivative of evolution operator gives evolution operator times Hamiltonian. And if we are taking derivative of wave function, then what are we going to get? So this u prime is replaced by minus I over h bar h u, and then there will be initial wave function to the right side. Okay. So I will write it down and show it on the next slide, but what do we see? We see a really important step, logical step. By taking derivative, time derivative of wave function, we will get the same wave function. Derivative of wave function is equal to wave function with some prefactor, some multiplier. This is really cool. So I'll probably write it in this spot. Minus I h bar h u psi 0. But the u times psi 0 can be replaced by psi, right? So what we are getting is time derivative of wave function equals this factors Hamiltonian times wave function. d dt psi plus minus over h bar h times psi. So if you were busy with something else, or if you were sleeping, please wake up and focus on this equation. This is something we need for the course. This is something that you are expected to memorize, cast it in different mathematical forms, and apply it to simple and complicated systems. So this is simplest form of time-dependent Schrödinger equation. Dependent Schrödinger equation. So by now we do not have enough muscles. I mean, intellectual muscles in skills, in mathematical skills, to go into more details. But we will accumulate how to cast Hamiltonian in the right way. But from here we see that it starts looking like differential equation. And you may have seen it in the past. Typically one uses time-independent Schrödinger equation, which is a little simpler, but it can be derived from this one. This is most general. And instead of postulating it, we did achieve it as an intellectual effort. We came philosophically where it comes from. So it is not a random design of equations. It is, there are ideas behind it. So today we got two ways to predict the future of an electron. Through evolution operator, through this infinitesimal phase accumulation, and through, we started our journey into predicting future with differential equation, Schrödinger equation, for it is a replacement of a wave equation for an electron. Time is over, enough. Thanks for coming. No lab today. Looking forward to see you Friday, same place, same time. I'll stay here in case there will be questions, objections, constructive suggestions.